Welcome everyone. Who here has been personally impacted by a security event or a security issue in the past? Okay, just what I thought. And those of you who didn't raise your hand, you probably might want to go and search through the internet for your personal data and maybe raise your hand at the end of this session. So my name is Ben Potter. I'm the security lead for the well-architected framework based out of our Melbourne office in Australia, if you haven't gotten the accent through already. So this session is about incident response and how we can automate. I'll be starting off with how to start your journey, even if you're a fairly mature organisation in terms of incident response processes, perhaps you're a financial institution, or even if you're a startup. I really hope you're going to get something out of this session. We're then going to go through an insider threat based on authentication issues and denies. And then we're going to move on to an instance or EC2 instance incident response and how we can automate a forensic investigation on that. This is quite a technical session. I have a lot of demo content, so we're praying that the internet is going to be working with us during this session. There is a lot of visuals, so there's plenty of seats down the front, so if you are a bit of eyesight issues like myself, please come down the front. For the rest of this session, I'm going to be Bob. I'm not going to be Ben. Let's put my security cap on here. So I've joined a DevOps team as the lead security guy in this organization. It's a marketing organization. We deal with a lot of customer data. Security is our #1 priority. My responsibilities as the security lead in my tribe, my DevOps team, I need to be aware of security events. I also need to put in preventative controls, and I also need to use automation, because it's only myself as the security lead. Of course, I've got an escalation path that I can take and go to the corporate security team, but I need to be the owner of security. In fact, everyone in my team is the owner of security. I'm going to share with you 2 interesting experiences. And we recently had a team member leave on some uneasy terms. Her name was Trudy. Could be Trudy the intruder, okay. I don't know though. So I'm going to share first how we can automatically respond to access denied attempts through Identity and Access Management Service and how we can automate that. And then secondly, we'll be going through and I'll be sharing you a solution for automating the incident response and forensics. And this is all about automation, code, and the tools based on open source tools that we're going to use. Where do we start? I started as Bob with the NIST Security Incident Handling Guide. So this paper is a little old. It doesn't even mention the word cloud once in it, but it's a really good place to start in terms of how to prepare your team, what processes and procedures that you should be aligning to. It also calls out that you should practice responding to an incident. Practice makes perfect, right? And as everyone needs to be a security owner in your organization, that echoes throughout the organization and you have a better outcome in the end. These are some of the resources that I used as Bob throughout my journey as being the security lead. So I started off with the AWS Security Center, and that links through to the AWS Compliance Center as well. There's a lot of great training material, documentation. I then went on to the AWS well-architected framework. So it has not only an overarching framework that allows me to better improve my architecture over time, but also has a security white paper with a number of design principles that I'll show you shortly. Finally on this, I have a really good reInvent presentation on incident response in the cloud from the reInvent last year. I also used a reInvent presentation again at the top there from last year, which was using Lambda as a security team. So it's only me as the primary security guy. So I need to use tools and automation to help protect my organization. I'm also going to be demoing the open source sleuth kit, with the autopsy tool. So this is file-based forensic analysis. That's all open source out there. And finally, the last link there is the AWS IR GitHub project. So there's many people that contribute to that project, and it includes many tools, including Margarita Shotgun, and also how to respond to access key compromise automatically as well. It's a command line based tool. So all the code from this session that I'm going to be showing you today is open source now on GitHub. I demoed it at the AWS Sydney Summit a few weeks ago. There's a few little missing pieces in terms of what we'll be demoing with the memory-based forensics that will be coming soon there. But for now, you can take a photo of that, check it out, and I really love to hear feedback on this open source project. So as I mentioned, the well-architected framework has a number of security design principles. The ones that are going to apply to this session that I learnt about and the best practices were automating security best practices. So again, automation, and I'm going to be using Lambda for that today. And also preparing for security events. So I need to prepare before they happen instead of wait till after the fact and then it's too late. And I really don't want my organization to have that reputational brand damage that can occur. So I did consider running a honeypot to try and trap Trudy from coming in, but I decided against it. I decided to use different indicators within my AWS accounts. Some of these include the CloudTrail, so any access denied attempts in CloudTrail I want to know about. Any access denied attempts to S3 buckets, because of course Trudy has all that inside knowledge of what all my bucket names are, all the roles, all of that. I want to make a bet that she's going to try and come in, and I want to be told when she does, or when anyone does, try to come into my AWS environment and try and protect against it. And of course, I want to know about abnormal behavior. And Guard Duty, the new AWS service, is going to help me detect that abnormal behavior as well. Is there an existing role or IAM user in my account that is doing something that is not normal for that user? So what I did when I started in the team, I enabled all the security logging services that I can in AWS. So I already had CloudTrail turned on, of course. So I enabled Guard Duty. I enabled all application and system logs, operating system logs, going into the CloudWatch log service, and also VPC flow logs. We didn't have these previously configured, and they give me a really good overview of what's occurring in the environment. Also AWS config, so it gives me a snapshot over time of what resources have changed and links in with CloudTrail to tell me who has changed over time. So the insider, Trudy, hey, I'm going to step through a solution of how I'm going to detect Trudy or any other adversary out there trying to get into my environment. So what I want is to be notified on any access denied attempts, who has attempted what and from where, and what the user or role that was denied. And also, I want to know who has actually modified that user or role in the past. Because again, we're thinking about an insider threat here, and I really want you guys out there to think about how this can apply to your environment. So I'm going to step through the solution now. So I have CloudTrail, triggers CloudWatch event, that I'll step through shortly how that works. I have an SNS topic. That SNS topic is listened to by a number of Lambda functions. I have access denied responders that get the history of the user or the role, and also the history of the user or role of the one that was actually denied. Then I push to a single SNS topic that is listened to by 2 Lambda functions. I can do Amazon Chime, or in the demo I'll be using Slack. So I got this Slack message once, soon after configuring this actually. So if we have a look at it, at the top there we've got our account ID, we've got access denied for user Trudy-backdoor. I probably should have seen that when I went through the credential report. Everyone checks the credential report, right? Yeah? Okay. It's a console login. I've got the source IP address. I've got the user agent as well. And I'm using a paid-for Whois service as well. And I'm populating all the Whois information from that particular IP address. So I can tell what the country is, the service provider, the actual geo-location, the real location, the IP address. So I can quickly determine if it's Tor or anonymizing VPN service. And also have the history down there for that particular user. But I reckon we should step into a demo. Let's see how the internet's working. So, as I mentioned, we have CloudTrail loggings already configured. We have CloudWatch event rules. So I've got 2 rules here for this. I've got an access denied event and a you're not authorized event. So if I drill down on that, we can see, apologies, I'm just going to zoom in there. You can see here I'm looking for error message of access denied or failed authentication. And then my target is that particular SNS topic. So if we go to Lambda now, I have a publish user trails history Lambda function. And you can tell this is Python. And I'll just scroll down. You can see I'm getting my IP geo data here. And I'm doing my CloudTrail lookup history from here. CloudTrail event, JSON loads. Cool, right? So let's give it a go, shall we? Just trying Trudy's real user and see what I get from that. Going to get an access denied, unless I happen to guess her password on a keyboard mash. There we go, access denied. And if I go through to Slack, there we go. I have my Slack notification of my IAM history of the actual IAM user and the history of who's performed the different actions over time on that user or the role, of course. And I've got my IP information there as well. At the moment, I'm routing through Sydney. Why wouldn't you, right? We're in London. So what I learned as Bob from that is what the automation that I put in place was really, really good, really awesome. It saved me so much time in having to trawl through CloudTrail. If I hadn't have configured that, I wouldn't have actually known that somebody was trying to make those access denied attempts on my account. Also want to point out that IAM users should only be allowed to assume roles. They shouldn't have any privilege directly assigned to them through policy, because with enforcing them to assume a role, I can enforce multi-factor authentication, which is a good security practice. I also want to think of how I can improve this over time. Is a simple Slack notification good enough? Should I put in more preventative controls to stop insider threats? Should I think about better isolation of roles and alignment with security policy into what that person's job role is? Yes, I should. And we pwned our ex-employee Trudy. Logs have been sent off for further investigation by law enforcement. I want to share with you now the next chapter. So this is how I am going to respond to an EC2 instance that's been compromised, that's been discovered by guard duty, but it could also be any other mechanism. So anything that can push an instance ID to an SNS topic. So many of the partner tools out there can do this, of course, or I can write my own scripts to push an instance ID to an SNS topic, and then the rest is taken care of for me. So you gotta bear with me. This solution's a little bit complicated. So I've got my SNS topic that listens to the instance ID. I'm then gonna verify that instance ID is okay. I don't wanna pull out this instance from running if it's the only one. It's my critical production single point of failure server. I'm then gonna invoke a step function, and let's step through what that does. So I'm gonna remove from auto scaling. I'm gonna snapshot any EBS attached volumes to that instance. Then gonna record all the EC2 metadata. So what the IP address details are, what AMI it was launched with, subnets it's in, all of that information. I'm gonna apply tags that it's under investigation, and then I'm gonna notify through the Slack channel to the entire tribe that this instance has been compromised and that an investigation is gonna automatically start. I'm then gonna isolate this instance by removing all existing security groups, and I'm gonna attach an isolation security group, which has no ingress and no egress permissions. The no egress permissions on this is incredibly important, because with egress permissions, if it still had an EC2 role and an adversary had access to it, then they could do anything that that role allows them access to, if they, of course, had access to the AWS APIs. We're then going to create a clean room using CloudFormation, completely separate VPC, and we're going to launch a forensic investigation instance, which has all the tools pre-built in an AMI, and we're going to run the basic forensics. The demo that's up on GitHub is only running file-based forensics, and really is just a demo for deleted files. But of course, you can take it and extend it, the code with what you want to do for your solution. We're then going to generate a report, and it takes 5 to 10 minutes, depending on the instance size and the volumes attached. Then we're going to send that through to the Slack channel as well. So if we recap, we're isolating the instance, so it's not doing any damage, but we're keeping it there in case we want to do further investigation. So I'm not a forensic expert, but I want to leave it there in place in case somebody else wants to in the future, and of course law enforcement, etc. So I woke up one morning to this message, again, soon after I put it in place. We have the account ID at the top, we have the instance ID, and the instance has been isolated due to a finding in guard duty. And then we have, just so the team's aware of what's going to happen next, we've got the steps for what the step function is going to perform. And it will also give us a link to where the information is in the S3 bucket. So some minutes later, I received this. Again, we've got the link to the bucket. And if we look down the bottom there, we have, this is a deleted file report from SleuthKit. Down the bottom there, we've got a deleted file in user bin named hacked. I know it's pretty obvious, but we could actually use this. If we knew what the file system contents were for the base AMI, we could actually do an automated diff between what good and normal looks like in a trusted golden image in the AMI with what a potentially compromised instance is. Right, let's have a look how this is going to work. If everyone can just stop your downloads on the internet, that would be appreciated. So we have our event here, which triggers through from guard duty. So guard duty can be configured with the CloudWatch event to trigger off this whole step function. So I'm going to manually execute the step function now. I'm passing it the instance ID. Normally this would be the SNS topic that would actually do the trigger. So we've got a started here. And I'll just drill down on the execution here. So we've got a capability in there to create a support ticket. So if you have a ticketing system that you want to integrate with, just place your code into there. We're going to start isolating the instance, wait for that to be completed. and then we're going to alert the security team. There we go. We've got our alert here that the instance has been isolated, and we've got the real instance ID in there. And we've also got this information here. So it's already being drained from the target group in the application load balancer. And this will step through preparing the instance for remediation and starting that forensic instance in the clean room. Let's just see how we're going here. So the instance used to have a security group of this particular name, auto scaling group. So if we just do a refresh here, we can now see the isolated security groups already been applied. We just did a refresh. If we drill down on that, we have no ingress or inbound permissions, and we have no outbound or egress permissions. So this instance is basically isolated from any network activity. If we go over to VPCs now, we have our incident response VPC. We have our VPC there. We have our subnets there. Just go back to that step function and see how that one's going. Oh, there we go. It's almost complete. We're just waiting for that forensic instance to boot up, and then we'll start running those basic sleuth kit commands on it. If we actually go over to EC2, run commands, we're using Systems Manager to run the commands based on the Systems Manager agent on the forensic instance, right? So that means I don't need to log into the forensic instance. This Zoom is killing me. Okay. Let's go step. And you can see here on the SSM activation job, I've got my details here in JSON, and I've got my snapshot ID of the snapshot that was taken of the instance there, availability zone, etc. I have my forensics report instance ID and all the case ID as well. That's just the dummy case ID that I've passed through. Cool. So it's all succeeded. And there we go. Where are we? Too many notifications. And there's my hacked file there from the Slack notification. So this is just details of the latest deleted files off the file system. Why I think this is relevant is an adversary who does gain access to that instance will try, if they do any file-based attacks or put any files or will maybe generate a log file or something like that, I can get the deleted files back from the snapshot I've taken using the sleuth kit. I can also use the autopsy tool, which is part of sleuth kit. It's got a nice graphical user interface under Windows to drill down and get more information about this particular file system. So I have here my victim duplicate of the disk, victim.dd. I can get all the deleted files through here as well and drill down. So I've got my visual representation. I can create a timeline of everything that's occurred on the file system, both what's active and what's deleted. But more importantly, so this is the mechanism I can compare against the golden image. You know, if this is an advanced persistent threat, it might be very difficult to determine what's going on. But by comparing back to what the base AMI is, it's really, really powerful. I can also import different hash sets here as well and compare against different hash sets out there for known bad things that can be found on file systems. What I can also do is, and not included in the GitHub project yet, I can also take a memory dump, and I've already taken a memory dump just as an example of a Windows instance that I was investigating earlier. Yes, I should have put the security updates in there, but these open source tools can be a bit funny with the latest libraries and modules in there. So I'm using open source memory imager, so I can use Linux Lime tool. So I'm using open source volatility memory forensics tool. Let me just zoom in there. So these are all the different commands. I'll just scroll up to the top, sorry guys. So I can get out of memory from the memory dump of the running instance, whether it's Linux or Windows, I can get process lists, I can get netstat information, I can even grab running executables out of the running memory and then do further analysis on that or save to a file and run it through like anti-malware or something like that. Incredibly powerful. I'll just show one I prepared earlier. Let's do a process list. So these are all the running processes on that instance at the time that I took the memory dump. So you can see I'm running PowerShell, etc. And again, I could compare this to the known good AMI to determine where I'm at this point in time. Let's see what else I can do. As this is a Windows instance, I could see what's on the clipboard. I know this one takes a few seconds. So by doing this, memory forensics and the file-based, I can get a picture of what's stored on disk and what's in memory. So any advanced persistent threats out there, and there are some that don't record anything to disk, I can get them out of memory by doing a memory dump. In the AWS IR tool that I had up earlier from GitHub, that actually has a tool called Margarita Shotgun, which automates the memory-based dump from Linux and automatically puts it into an S3 bucket as well. You can see here my clipboard analysis has happened, and somebody put G'day London on the clipboard. Hilarious. What else can I do? I can do a timeliner. So this will give me a timeline of what's in memory, or what has been in memory as well. Just give that one a few moments. While that's doing that, I just want to show you the Lambda functions that we've got that back these step functions. So I have my isolate instance here. And again, all these Lambda functions are part of the GitHub project out there as well. Here we go. And again, this is a Python. And it's simply looking at the ELB. Let's go to the ELB and just check that that instance is gone. So we're going to check the target group, And you can see I've only got 2 instances in there. I don't have one named victim. So it's automatically taken that instance out of the target group for the application load balancer. So my instance is isolated. Let me just check the tags on that, shall we? I should have known with the name of victim 5 that it was going to be a victim. So I have a key called isIsolated, and the value is instance isolated there. Cool. Let's go back here, and this lot of mash is the memory timeline from the volatility tool. So I can go through, and again, I can do a diff, or I can use this for further investigation from a properly qualified forensic investigator. So what we just achieved was something went bump in the night. In this case, it was guard duty detected it, which is really, really cool. But no human interaction was needed. So I didn't need to get out of bed. It was actually automatically detected and not found when it was too late, and our business was in the news. And I automatically got all that basic forensic investigation information. And also had the snapshot of all the information that I could do further analysis or call in an expert if I needed to. For once, the security system didn't break anything. Cool, that's good. We've got those checks in place. And I have that mechanism to compare against what good and bad is. What I learned that incidents are always badly timed, especially if you even know about them in the first place. If you look at the statistics on advanced persistent threats, it's many months on average that those adversaries are within an environment before they're discovered. Security incidents can cause incredible long-term damage, no matter how simple they are for your organisation. You absolutely need to prepare for an incident before it's too late. Awareness, training, and of course tools like I've demoed today will put you in a good place to respond to an incident. It's not the end, it's just the beginning. So it's the beginning of the journey. And I really recommend you practice through game days, not just your security team responding to an incident, but your entire team that supports the application, all the way up to the business owner's C-level, and of course, if you have a PR or marketing team as well, involve them in the process. Everyone should be a security owner. I always stay up to date with not only the latest in the industry news and Twitter and etc. out there, but also keep an eye on the AWS security blog, because you never know what really cool stuff is out there. There's a lot of these code samples that come from time to time, and in particular around incident response, Lambda functions to try and secure your AWS environment. So that's all I had for today. I really hope you'll go to the GitHub project, give it a go, and also keep an eye on it in the coming months. And I'm going to head straight to the AWS booth, where I'll be available there for any questions. But I thank you all for attending. Thank you.